Next, we have Chris, yeah, Stephen Patrick here, coming from Ida / UCLA / Johns Hopkins now, right?
So, hello, everyone. My name is Chris Mapasuk. I was a summer associate with OED last summer. And yeah, I'm thankful for everyone being able to listen to my talk today. And I'll go a little bit over my project today, which was implementing fast flexible space filling designs in R. So yeah, the main motivation behind this project was space filling designs are desirable for planning, modeling, and simulation test campaigns. Currently, there's actually no R function that provides these type of designs that are suitable for categorical data. So my project was essentially meant to solve this problem. Essentially, I wanted to generate a function that would be able to handle both categorical and continuous data, accommodate user inputs, and also be accessible as an open source technology for people to use. So the question is, how does fast flexible space filling designs relate to IDA's work? Well, IDA actually leverages design of experiment techniques to choose different test conditions when planning a test for military system. Here, I wanted to go over just the basic framework for designing a test. So it's basically just a step-by-step process involving planning experiments to ensure you get the data required for your system. The aspect that I highlighted here was a design aspect, and basically this design aspect is one of the most important aspects of this methodology, as we want to be able to generate the best design possible, so we're able to get the data required to fully evaluate our system. And ideally, when we're doing operational testing, you want to be able to collect your live data from the field, but sometimes this just isn't possible due to many different factors. Fortunately, this is where modeling and simulation comes in to fill in the gap. And oftentimes, scientists conduct simulations on computers, and they're able to, simulate these scenarios in a computer rather than having to test it in real life. And this data is able to augment, the experimental design process. And so fast flexible space filling designs are just one design option for modeling and simulation, and we'll talk more about that in a bit. So first, let's have an overview of space filling designs. So space filling designs are just a group of designs, and they're used to spread out points across the operational space. And as shown here in the image, the points are distributed throughout the design space. By the way.
It out of this session thing. Okay. Oh, sorry. Click on these buttons here.
Okay, now how do I point the?
Oh, I believe it is the. Does anybody from the last session remember how we did the laser?
It's the gray button.
Oh, there you go. There you go. Okay. Now you just, yeah.
Okay. Sorry, we'll get back to.
It's okay.
Yeah. So I'll just go over this slide again. But space filling designs are designs used to spread out points across the operational space, and as shown here, the points are spread throughout the design space. So that's for space filling designs. And then when you go down at the bottom image, which is right here, these are factorial designs. As you can see, the points are pushed to the exterior of the operational space. And here, I just wanted to, show the differences between our design, which is a space filling design, and the factorial design. So the algorithm that we created generates fast flexible designs. And these are useful for operational testing, as I mentioned, because they could take in designs or inputs with continuous and categorical data. And the table shown here just lists some basic examples of categorical data and continuous data. And I'll show you guys just a little sample input and example in the next slide. So here's just a simple implementation of the fast flexible design. And this is just a simple notional missile system example. So suppose military personnel wanted to assess how a system would perform under specific conditions. For example, testing, the accuracy of a missile. They would have to input different input factors. For example, wind speed, distance to target, and the launch platform. So here are some of the factors that I included in my simple example. And basically, they might also want to test some categorical factors such as the launch platform categorical, or which is a categorical data type. So here I listed categorical label A, B, and C. So basically they want to input these into an algorithm, which is our algorithm, and the output would give us the different test trials that they can run for their system, which I'll show you guys in the next slide. So here's just a code snippet that I wanted to show for a simple run through of my function. So first we create a list of inputs in a list D, and some of the inputs include wind speed, which I use from 1 to 500, range target 1 to 800, and platforms A, B, and C. Again, these are all arbitrary values, but I just wanted to do a simple example. Then we plug this into our input list, or into our function D, or FFF, where D is the input list and would represent the number of design points. R equals 10, which is the number of times the labels are shuffled, and N represents the number of points to generate for clustering. So once we plug these into our function, then we're able to generate our design. And if you guys want, come to my poster session to learn more about these parameters. So finally, the resulting output visualizations are space filling designs. And as you guys can see here from this diagram, the points are distributed throughout the design space. And then if you subset it into each of their individual factors, A, B, and C, there's also space filling properties as the points are distributed throughout the exterior. So this diagram is just meant to show that our design had space filling properties. So overall, I just wanted to end the quick presentation by restating the importance of this work. So these are just two memos that I attached. One comes directly from the Deputy Secretary of Defense. And this is just a memo that advocates for open source technologies. And essentially, I'm trying to make this project open source and people are able to accidentally download the function. And then the second memo is directly from DOT, the Director of Operational Testing and Evaluation. And this memo just talks about the significance of baseline designs and how they are significant in modeling and simulation testing. So overall, designing experiments for modeling and simulation can be highly complex, especially if there are multiple factor types. Luckily, we have these fast, flexible designs, which can be used when working simultaneously with continuous and categorical data. The function that we created generates designs that can be used for modeling and simulation. And coming soon, we'll be able to publish this as an R package, and people will be able to download it and use for themselves. So thank you to everyone for your contributions in helping me last summer and for helping me prepare for Data Work 2023 this year. And thank you guys for listening to my talk.